This is Unit 1, Topic 3 of the Honors Geometry Semester Exam Review. Question 17 says, if figure ABCD is congruent to figure EFGH, complete the congruent statements. So if we know that, then we know that the corresponding parts go in order. A goes with E, B goes with F, C goes with G, D goes with H, and therefore AB goes with EF. BC goes with FG, CD goes with GH, and AD goes with EH. Therefore, we can say that angle A is congruent to angle E, and we can say that BC is congruent, line segment BC is congruent to line segment FG. Question 18 says, if all corresponding sides of two figures are congruent, and all corresponding angles of the two figures are congruent, then the figures must be blank. Well, we pretty much just explained what congruency is with that statement, so all the figures must be congruent. Items 19 through 23 use the figure below, where point S is the midpoint of line segment WU. Therefore, WS is congruent to line segment US. Line segment WS is congruent to line segment US. We're trying to prove that triangle WSR is congruent to triangle UST. We're going to be using this to make sure we write our statements in the proper order. So question 19 says, to prove this congruence by SSS, what two congruent statements are needed in addition to line segment WS is congruent to line segment US. What this tells us is that we need to prove that the other two sides of the two triangles are congruent, the other two corresponding sides. So we need to prove that RW is congruent to TU and RS is congruent to TS. Therefore, we need to prove that WR or RW, it doesn't matter, is congruent to UT, and RS is congruent to TS. The order matters because corresponding sides need to match up, but if you wrote WR is congruent to UT or RW is congruent to TU, that won't change anything. All right, number 20 says to prove this congruent by SAS, what two congruent statements are needed in addition to line segment WS is congruent to line segment US? There's two different ways that we can do this. Since we've got one side, we can either use SAS with the angle to the left, to the right of it, and the side to make that the included angle, or we can do the angle to the left of it. So let's look at first at this scenario. So this means we'd need to prove that angle RSW was congruent to angle TSU. We need to use three letters because if we just wrote angle S, we wouldn't know which angle we're talking about. We also need to prove that RS, line segment RS, is congruent to line segment TS. If we do that, then we've got SAS. Remember that the order that you write it matters. The other case we can do is when we make the included angle the angle on the left. In this case, angle W and angle U. So we'd need to prove, and then to make that the included angle. So we'd need to prove that angle W is congruent to angle U. This time we can write it with one letter, just the vertex, because there's no question which angle we're talking about. However, you could also write angle RWS is congruent to angle TUS. We'd also need to prove that RW is congruent to TU. So there's two different ways that we can prove SAS. It doesn't matter which one you pick, just understanding that both work. Question 21 says, to prove this congruence by ASA, what two congruent statements are needed in addition to line segment WS is congruent to line segment US? Well, since we've got the side, and ASA means the side's going to be the included, we need to prove that these two sets of corresponding angles are congruent. Therefore, we need to prove that angle W is congruent to angle U, and we need to prove that angle RSW is congruent to angle TSU. If we do that, then we're good to go, and we've proven it by ASA. Our next one, question number 22, says to prove this congruence by AAS, what two congruent statements are needed in addition to line segment WS is congruent to line segment US? Well, that means we need the two angles before the side or the two angles after the side. So let's start with the two angles before. We'd need to prove this angle was congruent to this one and this one was congruent to this one. So that means we need to prove that angle R is congruent to angle T and angle W is congruent to angle U. If we do that, we've got AAS. If we wanted to do it a different way, we would need to prove the other two angles, where it's angle side from the right-hand side. So we'd still need to prove that angle R is congruent to angle T, but we then need to prove this other angle. So we've got angle R is congruent to angle T, but we would also need to prove that angle RSW is congruent to angle TSU. So either one of these scenarios works. It doesn't matter which one you pick because they both prove congruency using AAS. Finally, in question 23, it says if line segment RW is congruent to line segment TU, so RW was congruent to TU, and angle R was congruent to angle T, must triangle RWS be congruent to triangle TUS? Justify your answer. Well, what we see is that we have side-side angle, or angle side-side. And from that we know it does not prove triangle congruency. It is not a congruence theorem that we've learned, or a congruence postulate. So it could be congruent. It's important to understand that it could be congruent. It just doesn't prove that it's always going to be congruent. So again, no, triangle RWS is not necessarily congruent to triangle TUS because the information given is SSA, which is not a congruence postulate. Question 24 says Consuela wants to determine the length of a power line that will be stretched over a lake. So she's looking at this power line. She cannot walk through the lake. She was able to take some measurements hoping to determine the length of the power line. Her measurements are shown below. Consuela believes that the length of the power line is 625 feet, but she's not sure how to explain this to her boss. Using what you know about triangle congruence, help Consuela by writing a brief report as to why the length of the power line is 625 feet. Well, looking at this, we see that one side of this triangle is 450 feet, and in our other triangle, we also have a side that's 450 feet. That means that these two sides are congruent. Additionally, we see that this side is 500 feet, as is this side. Therefore, those two sides must be corresponding and are congruent. Finally, we see that we have these two angles which must be congruent because they're vertical angles. And by looking at that information, we have side, angle, side, so side, angle, side, which is a congruence postulate that determines that these two triangles are congruent. If we know that these two triangles are congruent, then we can use corresponding parts of congruent triangles are congruent, so CPCTC, to prove that if this is 625 feet, then this power line must also be 625 feet. Therefore, using that, we're going to write a brief report to explain this. So in writing, we can say the 500-foot sides of the two triangles are congruent. The 450-foot sides of the two triangles are congruent. The angles included between the 450-foot side and the 500-foot side of each triangle are congruent because they are vertical angles. Therefore, Due to the side-angle side SAS congruence postulate, the two triangles are congruent. Finally, using CPCTC, corresponding parts of congruent triangles are congruent. The other corresponding sides of the triangles are congruent, thereby making the length of the power line 625 feet. In items 25 through 30 below, information is given about triangles ABC and FED. State whether the triangles can be proven congruent by ASA, SSS, AAS, or SAS. If the triangles cannot be proven congruent, state why. So in question 25, we're told that AB is congruent to FE, AC is congruent to FD, and angle A is congruent to angle F. From this, we can see that they're going to be congruent by SAS, since we're given a side, angle, and a side for each of these. Question 26 says, angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. Well, this means we have AAA, and we know that means that they cannot be proven congruent. And this is because AAA can't prove two triangles congruent. It could be a dilation. 27 says angle A is congruent to angle F, angle B is congruent to angle E, and AB is congruent to FE. Well, this one, we can see that they're going to be congruent, and they're going to be congruent by angle side angle, because what we have is an angle, an included side, and another angle, and that proves triangle congruency. Question 28 says AB is congruent to FE, AC is congruent to FD, and BC is congruent to ED. We can very well see that this is going to be congruent by SSS because all three corresponding sides are congruent. Question 29 says angle B is congruent to angle E, AC is congruent to FD, and BC is congruent to ED. Unfortunately, with this one, we can't prove triangle congruency because we've got a side, and an angle. And that alone doesn't determine triangle congruency for certain. It is possible, but we can't prove it because SSA is not one of our triangle congruency postulates. Finally, with question 30, we're told angle A is congruent to angle F, AB is congruent to FE, and angle C is congruent to angle D. Well, this does prove congruency, and they're going to be congruent by AAS. What this tells us is that we've got an angle, and a side. And basically, if we know two angles, we know the third. And so we've got angle, side, angle, which we already know proves it, which is why AAS also proves triangle congruency. And this ends Unit 1, Topic 3.